started here. As I said, I'm Santona. We've got Ori, Julien, Holden, and Jacques who have already given awesome talks, and you guys had a lot of questions for them earlier. So hopefully we can open up towards the end of this panel for additional audience questions. But I have a few that I'd like to start with. Easy balls first, softballs first. What excites you most about working on and in the open source domain? And anyone can answer and pass around.
Okay. So one thing I love about open source, I think I love the dynamics. It's like nobody's reporting to anyone, right? Especially if you work in those projects with mixed contributors from various areas. And so we work together. We have to work together. It has to be collaborative, right? Like there's not like nobody's going to put rank on you. We are in the open. We have to behave. We have to figure out how to work together. I like the dynamics. You get to work with people that are great. I don't know. I got the chance to work with Wes McKinney, Ryan Blue, a bunch of others, Jacques, and Holden. And those people, they wouldn't work all at the same company anyway, right? But you get to work with all of them, like in those projects. And I think I love this. I think this great building relationships and figuring how we make it work. And I think that it works is really open source kind of fosters this environment. I know it's not true for every project, but it's been true for the projects I worked on. So I just pretend it's always true like this.
Yeah. So I would say one of the things that I really like about open source is that the longest job I've had is 3 years. But despite that, I still get to know the same people, and I also get to work on the same code. So I've worked on this project for like over a decade, which makes me feel really old. But you know, it's nice, and you get to know the people, and you can kind of build a community that's still like professionally interested in the same stuff, but isn't necessarily your coworkers. I would say that I have slightly different experiences regarding like everyone behaving. But generally people, I would say, behave, I don't know, it doesn't seem to me worse or better than how people have behaved at companies, to me, but that's my personal take.
I think one of the things that's great about open source that I've appreciated is that anybody can come to open source. And it's about your contribution. It's not necessarily about where you came from or what you did before. So I'm someone who had a fairly atypical path to my career. I didn't start in engineering. It just happened to kind of land in it later in my career. And I always am fascinated by the kinds of people that show up in open source that have an interest, and then they start to contribute, and then it becomes a key part of them, this domain that they maybe had never been exposed before. And so to give you a concrete example of this, there was someone I worked with in the past in open source who had been a front-end game developer, had developed games in the browser for people to play with, and had somehow gone to a talk by someone about an open source project and decided to contribute something to it. And then over the next few years became prolific in doing all of this data processing coding because they were passionate about it. And no one said when they came in the door the first time, hey, you don't have a bunch of database development experience, you can't work on this. It's not like that. It's like, hey, if you come and you bring value, you're appreciated, and it's about what you're doing today. There's concepts of like karma and whatnot, but the reality is in most open source communities, it's the people who do work and volunteer their time. They're the ones that have the impact on those projects. It's not based on some kind of authority or past experience. It's about what you're doing today for that community, which I really appreciate.
So, let me ask a follow-on question real quick. Do you feel like there's enough coaching within the oh, no, okay. So if someone raises a bad first PR, this is my anxiety around it, right? What happens? You just ignore it, or?
So I would say it depends a lot on the project, right? In Spark, the default is if they don't like your code, they will not tell you. You will just be ignored. This is not good, right? To be clear, we should do better. But that is how it is in Spark. In other projects, though, I've seen people be much more responsive to people. In general, I would say it's kind of like the smaller projects are more likely to have people who are passionate about getting more people involved with their project. Like, I still want more people to be involved with Spark, but also, frankly, like, oh God, I can't look at every PR. So I just look at the ones that are in my like very narrow domain. Or if a friend tells me like, hey, please look at this, right? Whereas like if someone showed up and wanted to contribute a PR to my project to like fight health insurance denials, I would probably spend way more time helping them have that PR be successful than it would take me to write that code myself, even just because it's like, yeah, I want other people to be involved here, and I know that we don't have that right now. But like if anyone is nervous about raising a first PR, feel free to find me and send it to me first, and I am happy to tell you in a non-public fashion if it looks okay or not, if that will help anyone.
I think that's a good point, right? There's really a tension. You know, you have a number of maintainers or whatever the title is in this project, and they have limited attention, right? And they have the entire world, like all the contributors, users, everybody needs their attention. And it's really hard, right? Like you can't just pay attention to everything. And so there's a bit of, there's literally no coaching on people. How do you contribute something or present your contribution in a way that's more likely to get people's attention? Because sometimes there's going to ignore it. It's just, there's too many things. We can't reply to everything. And it's just not bad intention, but it's just like, hey, it fell off the shelf. Anyway, nobody replied. And so it's hard to do a good job at replying to everyone and coaching them one PR at a time into presenting things better. And also as a contributor, it's okay to kind of pull the attention, right? Maybe you build a relationship with one of the contributor that can help you, right? Or maybe you need to know whose attention you need to get on your contribution. You need to know whether you need to agree on how you're going to do it before you start submitting code. Maybe the PR is not the best thing to start with. Maybe the best thing to start with is just agreeing on how it's going to be contributed. Like, does this align with what the project needs and so on? And so, Holden was talking about, if it's a friend who's asking, is more likely to have my attention. Building relationships with the maintainers, like, talking to them, or like all of that, it helps, right? Because now you're not just like another people requesting attention. And sometimes people open a PR and then never show up, right? Like people spend time giving them a review, then nothing happens. So it works on both ends, right? Of kind of how do we make this relationship build a little bit more, make it more personal, and achieve the, getting somewhere. It's something to pay attention to.
Okay. Is it okay if I continue this? Sorry. I also wanted to mention that actually, so I did get really good mentoring from Google Summer of Code. And that like obviously doesn't touch all that many people each year. But that was a thing where people signed up to mentor college students into how to contribute to open source projects. And that is like how I would say that was probably like the turning point for me, where it went from like I can kind of submit a patch, but I don't really know what's expected of me, to like understanding when is a good time to submit a patch, when is a good time to ask a question. And so it's totally normal to not have that like instinct correct off the bat, and don't feel bad if you get it wrong.
I was just going to reinforce something that Holden said about the younger the project, the smaller the project, the faster it is for you to build a relationship because there's less noise, right? If you're a big project like Spark, you have a huge amount of contributions. Frankly, there isn't that much incentive for people to try to get more contributors. They're just coming all the time anyway, right? If you're a small project, you're trying to get established. You spend a lot of time trying to be like, oh, let me get someone else to contribute. You get excited when people contribute little teeny things. And so if you're interested in contributing to something, a young project, like an old project that's small, that's a different thing. A young project that's small, that usually means that it's probably someone who's getting something started, a group of people who are getting something started, and it's a good opportunity. I think the other thing there's this phrase that many people use called karma. They use it in different ways. We use it in just common language. In a community, you have to think about, what you're asking and what you're giving, right? And early on in a relationship, you often have to give more than you get. But then over time, you kind of build up a relationship and a rapport. And so to that point, right, like if the thing you want is you want the code to be this way instead of that way, showing up in an open source community and saying like, it should be this instead of that, is kind of asking a lot of the community without giving a lot, right? Whereas, as examples of giving feedback on reviews, like one of the things that maintainers get struggle with is just looking at contributions. So if you're interested in an open source community and want to contribute, one of the things you contribute is reviewing patches, right? Even if you don't know everything, you can try to be like, oh, I saw this thing. I think that might be a test case that would be good to be added. Adding documentation for things that confused you when you were trying to figure it out. And so what happens is that those things, like there's a lot of noise, right? You're maintaining a project. There's a lot of people coming up and saying all sorts of things on the mailing list and whatnot. And so someone who's helping all of a sudden is someone you start to recognize as a maintainer, and you say, hey, that's someone who I appreciate. They're doing stuff for the community. That's someone who I really want to make successful as well. And that builds up that sort of karma so that when you do put that first PR in for that piece of code that you really wanted to change, which may have been what you really wanted to do all along, that there's a reason that people are paying attention because you've invested in this. It's not just transactional, that you care about the community itself.
So I wanna transition into talking about Iceberg, but I think there's a good question here that I can direct to you, which will help us transition. So for a little bit of context, Upsolver, we had we still have this product. It's a streaming lakehouse, highly efficient and optimized, and it was built like just an S3. Data's an S3. We use Hive, but we do a bunch of compactions and stuff. And then Iceberg started becoming big, and we sort of like, yeah, let's go do this, right? Like it had a lot of the same capabilities that we were building. It was missing a little bit in terms of like streaming updates and stuff. So as Upsolver, we decided instead of sort of going to market with, okay, this is the same thing, but it's ours. We were like, we're gonna offer managed Iceberg service. So I want to hear from. I mean, I was there too, as part of that thought process. But I want to hear from you around like why this this like embracing of open source there.
In the management.
Yeah, in Upsolver's evolution.
Yeah, I think that Upsolver has been doing data lake projects for the last almost 7 years, and always we've been doing the combination of ETL together with into the lake and managing the lake. So you could use Upsolver to build your lake tables, but you would need to use it for both ingestion and for managing the data. One of the reasons we did that there wasn't a clear spec of how you should manage a data lake, and definitely not any path to making that data accessible throughout the entire warehouses. We saw Iceberg as a huge opportunity. First of all, because there was a clear spec of how we should be building a data lake, so every possible engine would be able to query it. And second, because you could collaborate with other companies and evolve the lakehouse into actually being as good as the warehouse. In the days of the lake, like we didn't have ACID that works, a lot of performance problems. So we could name the challenges. Upsolver spent maybe a couple of years improving its ability to do merges into Hive tables. Then we brought that into Iceberg. So there were a lot of limitations that prevented companies from replacing their warehouse with a lakehouse. I think the Iceberg is pretty much the end of that era where you need to settle on the lake on going to the warehouse because it's easier, because it has more capabilities. And that caused us to also change our product. And instead of selling ETL and Iceberg management together, we decided to sell them separately. And today we offer management of Iceberg, optimization of Iceberg, regardless of what companies do for ETL. If it wasn't for Iceberg, we wouldn't be able to do that. And that was definitely an important step for Upsolver.
Thank you. So in talking about lakehouses and open table formats, and this could go a lot of different ways and could be a long discussion, but let's just ask, what are some of the factors that sort of contributed to the emergence of the lakehouse or open table formats?
I can start. I'm sure people have a lot of opinions. I think there's one factor. I think there's two main factors, in my opinion. On one way, people add data in kind of data lake in S3 or something, and then often you do some like ingestion, transformation, you prepare it, and then it goes into maybe Snowflake or BigQuery, and there you have analysts doing SQL or more things like that, right? And then it's kind of fine for a bit, or you have this one way, and then at some point it clearly becomes silos, right? Like people who work in the SQL environment, they do derived data set, and then you need them in your data lake as well, and you start having this friction of like, oh, the data is in the wrong side, of we have unclear dependencies and so on. So there's kind of this notion of breaking silos of, to use a warehouse, you had to import the data into it. And then if you have derived data set in there, you need to pull them out in the other thing, and like having those silos and moving data around, and it's expensive and it's complex and it's brittle. And then the other aspect is really like not wanting to be vendor locked in, right? Like, so there's really an appealing way of like, oh, now I have this centralized place where I have data and I can use Snowflake with it. I can use BigQuery, I can use Spark, I can use Dremio, I can use your various things. And it's really easy to try a new one, because as if everybody understands Iceberg, like I can try this new vendor, it's easy. This table we were doing with Snowflake, but maybe it's too expensive. I'll write Trino, we'll try Trino on this and just this table. And the fact that the storage is shared and it has this very flexibility, that's really good for the users. And I think in general, customers of those engines, they were liking this aspect. Oh, I'm not locked in anymore. I'm one, not siloed, two, not locked into a vendor. I like that, right? There's kind of like these, like general direction that helps the creation of Iceberg.
I think the other thing I'd say is that simplicity allows a broader group of users to interact with something. And so there's this need to abstract things away. Like if you think about like the big data to Hadoop, to Spark and Data Lake and now Lakehouse, right? The progression there has been to figure out what are the good ingredients from those things. Like it wasn't all bad. There's a lot of really good ideas there. But there's also a lot of stuff where you had to be extremely sophisticated in how the tool worked in order to use the tool, right? And that just means that you limit the population of people who can interact with those technologies. And so creating the abstractions that take these really good ingredients like, standardized storage and standardized formats like Parquet, and turning that into something that's a little bit more abstract so that you can have a much, much wider group of users interacting with it, I think is also a key characteristic. I think that Julien hit really the two that I think drove some of the initial stuff. I think that the reason that it is important to the entire world, as opposed to just say the big tech organizations, is because the rest of the world, they don't have 50 or 100 or 500 data engineers that know how to write, Scala code and Python and 5 other different languages in order to work with this stuff. They want to work with higher level abstractions. And I think that that the table formats are allowing that to occur, but still having the benefits that we had from sort of those big data movements.
Okay, great. So let's talk to the data professionals that are here to learn Iceberg today. How should we approach data engineering, data architecture in the Lakehouse era? What are the things that are like important to know to get started with?
Well, when we talk about practitioners, the question if it's practitioners or data engineers. Data engineers really need to understand the unbundling that was described very well in the previous session. Like what are all the pieces, what to expect, how they will interact, how billing will go. Like for data engineers, it's definitely a brave new world. There's a lot to cover. I think for data practitioners, life pretty much remained the same. I'm curious to see if you're thinking about it differently, but for them, it's the data infrastructure. It's supposed to, Iceberg Lakehouse needs to serve the data warehouse function. And for them, it needs to be as similar to the source as possible. But curious if you think differently.
No, I think that makes sense. The main thing is, I think it helps with before you would have to worry about where the data was and where you can query it, and you have to use different tools and they behave differently and so on. Now there's like, oh, actually the data exists, right? Like it's kind of, and I can query it in my data, in SQL, or I can use it with my machine learning, and they're less silos, so they have less to worry about this, right? And that's one of the benefits of breaking up a bit these artificially constrained worlds.
Yeah. So I would say similarly, I think data engineers probably need to understand under the hood how a bunch of stuff works. Especially like if you come from like a search or Lucene background, you've probably got a pretty good idea of how some of these things are implemented. For data scientists, hopefully not too much. But I would say the danger that we've created for data analysts and data scientists is that before, to a certain extent, the data that was provided was safe, right? Like it was subsets of data that you would reasonably want to query. But now you're probably going to have everything. And it's really easy to accidentally use 1,000 computers for 1,000 hours. And Amazon will happily rent those to you. However, your accounting department might not be so happy. So I think just keep an eye on sort of what you're doing. And when you go to jump into a new table, don't assume that it's like safe to run a select star from. It might not be. Describe the table first. Look at it. Yeah. So, okay. So yes, yeah. So there's the permission-based thing. So by safe, I don't mean necessarily like legal compliance safe. I would say one of the things that I've noticed is like certainly places do a very good job of locking down sensitive data, but they maybe don't do a great job of saying like, hey, this data is really expensive for us to query, or like this data is living in semi-cold storage, so it's going to cost us more to query. Places don't currently as much prevent people from accidentally foot gunning themselves by querying more than they intended to. So be careful. Look at your query plans. They might be doing more than you expect.
Yeah, I have two additional things to add to the question. I think the first is I'm going to make an observation, which is I think that the word data engineer means something different for people who are working in Spark community and people who are working in Snowflake. And it's really, I think it's important to call that out because they're different levels. And so like, I would say that if I was talking to a Snowflake data engineer, I'd say, you don't need to know any of the internals of how Iceberg works. Like it's just, you say create Iceberg table and saying instead of create table, and then you can easily use it in your other systems, right? Whereas I think that, if you're someone who's more involved in some of these other technologies like Spark and Databricks and whatnot, data engineer can often carry a meaning that is a further down the spectrum on software engineer from analyst, if that's the spectrum there. So that's the first thought I had. I think the second thought is that if you look at the big guys that use Iceberg the most, or any of these formats, they're kind of religious about them, right? Like Netflix or Apple or Adobe or something like that. They're pretty religious and they're like, oh, we use it everywhere and you should use it everywhere too. I think that that's a good goal, but I think you should be cautious and approach this from, I'm just going to start out with one use case or one table, and I'm going to start to interact with this and get comfortable with it. You don't have to go all in to take advantage of these things, right? Because the benefit of these formats is that they do work in all of the systems. So if you keep most of your stuff in one format and then you start using, like the native format of System X, but then you say, okay, I'm going to, I've got this new use case. I'm going to have this new use case. I'm going to start using an Iceberg table for that new use case. That's the way that I would recommend as a data practitioner you approach this, is do it a little at a time, get comfortable with it, get familiar with it, because every technology, there are strengths and weaknesses. There are different compromises than maybe what you're used to. So don't feel like it's like, and to me in general, the concept of the Big Bang migration, we all know that is horrible. It doesn't work very well. By the time you get it done, everything's changed. And so just do it a little at a time. Like to me, it's like tomorrow when you create a table, create it at Iceberg, right? The tools have enough support now that you can start to do that and get comfortable with it. It's not a big decision to go and start using Iceberg. It's a small decision on one table. And if you do that, you'll get comfortable with it. You'll realize that there's these strengths. The next time someone asks for a copy of that, you can just say, hey, here's the reference to it, as opposed to, oh, let me copy it out and extract it and import it into a different system. And you'll start to get those benefits. So don't think about it as a big thing. Think about it as little teeny steps along the way.
So yeah, that's a big plus one. I would say even actually at Netflix, right? We've done our migration to Iceberg slowly over time. And it did start with people like explicitly creating Iceberg tables. And then it was like, okay, we'll make the default for all new tables Iceberg. And then we finally started to migrate tables with certain properties into Iceberg that we, have increasingly migrated more and more of them. So even at Netflix, which is like the original home of it, it wasn't a big bang migration. Big bang migrations very rarely succeed. And I say this as someone who has learned that the hard way repeatedly. Yes, there we go.
We all.
Yeah. So there's the company making a decision to switch all of the data format into Iceberg, and then there's the individual decision of, I'm going to get started with Iceberg. And definitely at the individual level, getting your feet wet. And it's easy. It's like, especially with the integrations that have come out with various, common tools that folks use, it's really easy to get started. And again, not to pitch the training too much, but we're going to do a little bit of that, like just getting your feet wet with Iceberg in a bit. Okay, so let's talk about what sectors or fields, and however you want to interpret this is fine, within the data sphere is suitable for the lakehouse. So is somewhere that the lakehouse architecture fits well, as opposed to a lake and as opposed to a warehouse, a more traditional warehouse. So I was thinking in terms of like analytics versus ML or batch versus streaming, but really like take this wherever you want to.
So I'd maybe instead say, and then this is perhaps my bias, but like I think the lakehouse fits a lot of use cases. And so it's in a way, it's easier to talk about the places where it really doesn't work today, right? And those are things where we need things that are real time. We need really fast updates, or we have a lot of concurrent separate systems trying to update the same table, or we have lots of small individual changes that we can't batch together. And that's kind of where, like, right now, no bueno. You can use it, right? Like, and this is like, how do I say this? By real time, right? Like, I'm not talking like 1 minute. I'm talking like under that, right? When you're starting to get into the point where you're like, I don't know if Flink is fast enough. That's where you should probably be using specialized in-memory things. AI, ML stuff, it depends a lot on what you're doing. Feature stores, not great there, in my personal opinion. I think there are better systems to use for feature stores. Do other people have thoughts?
I was just going to reiterate. Yeah, I think the closer you get to real time, obviously OLTP, not at all. Not even once. Real time, I think, I do think that, there was a question earlier, I think at the end of Julien's talk about ML and AI and how that influences things. I think that there's another generation of stuff that's going to happen here. I think that if you haven't looked at the Lance file format, it's an interesting thing to look at. I have no involvement. I know some of the guys that work on it, people work on it, but those ideas I think are going to come back into some of these things, so that more of those use cases that may not be quite right, like the super wide schema is right in the Parquet community right now, working on the footer to improve that. The point lookups, something that Parquet and Iceberg have not been exceptionally good at. They've done okay at. There's some index stuff, but it's not been the strength of those things. So I think that there are definitely some use cases. I would say that, like, in the way that you phrased it, like I think you said lake house, or warehouse. I think that, we're either at the point or very close to the point that I don't see any good arguments to use lake and not lake house, except in the case that you're currently working with unstructured information, like your images, right? We don't tell people put your images inside of an Iceberg table. I'm not saying that people can't do it. I don't know of a lot of people who are. But I generally don't think that most people use warehouse for that, even though some people are trying to say, yes, use your warehouse for that as well. But in the context of lake, so lake, yeah, just put a bunch of images there. That's fine. Lake house and warehouse, I think that they're pretty close to interchangeable now. And so generally speaking, the things that warehouses are good at, things that lake houses are good at, and vice versa. With the exception that, like, obviously we talked before about the benefits that Lakehouse has that proprietary format inside of a single warehouse doesn't have.
I think there's one little thing. I think I was thinking also in the term of, so in the Lakehouse, all of that, we're thinking in terms of batch processing, right? So we talk about how it's optimized for bulk update, and we do batch processing and so on. And often you have an interaction between the streaming world and the batch world, right? So you have streaming data, and there's this same silo effect of one comes before the other. It's like you have streaming, and maybe you have streaming transformation, you use a Flink and so on, and at some point it gets archived into your data lake, right? You kind of have something like every 10 minutes it adds partitions to an Iceberg table or something, then it gets compacted. And then you have this thing, and then, this data we can use in some other ways. But actually, it's the same artificial separation as before the data lake and your warehouse, and then you actually end up needing to have data go back and forth between the two. And those streaming data set that, let's say they live in Kafka, right? There's kind of a duality of you can run it in streaming and you can archive them into a blob storage for batch processing. But it works the other way around. You're also going to have batch processes that generate maybe key values that are going to be looked up from a streaming jobs, right? So you kind of need to feed back into it, especially in machine learning, right? Like generating a model that might be applied in streaming is also the same mechanism. Or like we go to the batch world, we do things, we generate something like an asset, and it gets pushed back and it's used in a streaming world, whether it's request on a service or a stream consumed from Kafka when you apply something. And so I think as an ecosystem, we need to progress around this. So, like Iceberg ate up like the data lake, how we have a nice abstraction there. And I think we need to keep having nicer abstraction on how those two things work together, right? Like I've seen many different in-house solution to this, or this is how we push key values, indices to the stream so it can do lookup, or how we archive our things, and it's way too, kind of clunky, not like it works, but it's kind of, you have to know exactly how it works to use it well. So I think there's lots that needs to be done in this area. And maybe, I don't know, like maybe someone here would start a project to kind of standardize how we do this and have a nice abstraction.
Just to add, because I agree with almost everything said here, I think that streaming has been a challenge with Iceberg. So I understand the Hoodie guys saying that Hoodie is the streaming format. I understand why they're saying that. Our experience, we're mostly seeing streaming workloads. It worked. We managed to work around it in Hive, and in Iceberg we kept hitting barrier after barrier. Like this, I think that around 12, 13 months ago, we started trying to add support for equality deletes in Iceberg. We needed to go change Presto, go change Trino. So today, if you have a workload with tens of thousands of updates per second and you use Trino, yes, we have a solution. We'll go to Snowflake, there isn't a solution yet. And there were a bunch of PRs that we want to add, adding streaming APIs into Iceberg, handling commit contention, compacting equality deletes fetch, so even writing equality deletes. So I've talked to potential customers that are even coming from that are Iceberg PMC members, or they're not able to solve CDC into Iceberg in a good way because they want to do it in real time and not in batch. I think Iceberg was born in batch, and I think this is maybe the lowest hanging fruit right now to make Iceberg good enough for streaming. I think we are months away from actually having a good offering there. And I would say maybe looking further ahead, like we're seeing a lot of customers where they want to go from all the top level aggregations and go down into almost a needle in a haystack query, but not as a feature store. But I just want to see what this IP has done in order to do better cybersecurity. I think the concept of secondary indexing has been introduced to multiple warehouses in a way that's not open, and adding that to Iceberg will allow it to extend further in the analytics space, and also maybe be a better fit for in-app dashboards and those kind of things that you sometimes take an additional database to do serving, but most of the customers would start with something like an Iceberg with a lake, with a Parquet-based solution, if given the option.
I think there's one other thing that you reminded me of that I think is something that like I spent the last couple of years in the Snowflake world. Before that, I was a lot in the data lake world, and so it's been this interesting kind of world of looking at two different worlds and seeing how they approach things differently. One of the really interesting things that Snowflake is good at is they have this type called variant. And if you don't follow the Iceberg community, it's been proposed as an additional data type to the specification inside of Iceberg. And so it's something that you see a lot of, which is like, I got all these different processes, they're producing data, the scheme of all the different things is different, and I don't want to have to canonicalize it before I put it in a format, right? So if you look at Iceberg today, you generally are expected to canonicalize things. It doesn't mean you can't put a JSON blob someplace, but that's not going to be an efficient retrieval. And I think that this particular pattern is one that I think there's going to be a lot of progress this year on in Iceberg. And there's a very specific thing inside of that makes it really interesting. And it's one of the reasons that I think people have enjoyed using Snowflake for these kinds of workloads. And it's called, I think Snowflake calls it subcolumnarization, which is generally speaking, when you store like a blob of stuff that's unschemed, you kind of store it all together. And that means that every time you want to get one value out of that junk, you have to like read through all the junk to find the one value you want for each of those records. Subcolumnarization is about the idea of actually storing individuals' values separately, like saying, hey, you know what, I always hit these 3 fields in that junk because those 3 fields always exist, and I'm going to extract those out and store those separately. And so when I'm interacting as a user, I get high performance interacting with what is effectively semi-structured or unstructured data, or I guess I would say semi-structured data that's not schemed at write time. And I think that that's probably one of the other cases where I think the table formats are not great right now, is working with data that's not schemed at write time and making it still perform it for end users.
Great, thank you. And my phone's locked. Okay, great. So I wanna piggyback off of something that was said. So never, I think the phrase was never use a lakehouse as a database, not once. which I agree with. So let's say I'm an ML engineer and I have a ML service that has a proper database that's doing the online sort of inference work, and then I'm using proper message queues for messaging. I still, as Julien pointed out, I still have a batch system, right, where I'm storing historical data that are featurized, and I can retrieve those during even during online inference sometimes. So is this a setup where, and I mean, I'm describing a setup that you know I've built previously. So is this a setup where you would, I mean, I think the answer is a very trivially yes. Like you would very easily replace that lake that used to be for the batch workloads with a lakehouse without losing anything. And what I'm hearing is you can't conceive of replacing the online part with a lakehouse. So okay, that makes sense. Now, the other thing that we're encountering sort of at that edge, at that intersection of the online and the offline components is specialized databases, right? So we're seeing the emergence of vector databases and graph databases. So my question is around where do you see the lakehouse in that space of vector databases, specialized feature stores? Is there some intersection there, or is it complementary? And I mean, especially as an individual contributor or as a team deciding to make these purchases, right? How do I evaluate a lakehouse when I'm also evaluating these specialized databases?
I think there's a really important distinction to be made about what you said. And so it depends on how people interpret those words. The idea that you can have storage in a blob storage system and then have a user experience that provides a certain kind of database experience, whether that's a vector store or an OLTP database or an OLAP database, right? All of those things exist. Generally speaking, when we talk about lakehouse, we're generally talking about OLAP use cases. And so my expectation is that whether we call it Lakehouse or not, there will be a maturing of what I would describe as sort of stateless databases running on top of blob storage across all of the use cases. Now, they're developing independently, but my expectation is that that's a common pattern that will exist across everything, right? Like one of the interesting things is that like while S3 was worse than all other storage when it was launched, it's actually better than most storage now, right? Like S3 has gotten so much faster, so much more, had so much more capability about what you can do with it than when it first started. That all of a sudden a lot of patterns are possible now, right? Like I think that like when Iceberg started, the reason that the catalog exists was because S3 wouldn't allow you to do transactional put and replace or check and replace. But I think that there's actually capability to do that now. Where there was, I don't remember the exact details. There's more capability than there was back then, anyway. And so my expectation is that all of the different kinds of data stores, my expectation is that they will all become successful as patterns of stateless or semi-stateless stuff that sits on top of blob storage. And how complex that semi-statelessness is in terms of caching and everything else may be different for different use cases. But I think that will become the dominant pattern. Whether the different use cases all fall under the category of Iceberg or Lakehouse, to me is a bigger question. But I think there's a general attraction in all of those worlds to, hey, let's use blob storage as the primary storage, right? Like when you talk about things like Aurora, right, which is basically Postgres and MySQL on top of branded inside of Amazon, right? That works on top of blob storage. Like they basically made the storage engine side, and it's not just blob storage, there's stuff that's on top of it. But basically that's that pattern. And so I think that there will continue to be a growth of that pattern, whether or not they actually get categorized as Lakehouse or something else.
Yes. I think just the minor thing, I think like, so for example, if you think of RAG, right, like using a vector database, right, and you have a very small budget, like there's a request from the user coming in, right, and you're going, oh, I'm going to do this, and then I'm calling that vector database, and then I call the LLM, and then I do this, right? So there's a whole pipeline of things you call, and you have a certain budget of you want to return something in a certain amount of time. So that pushes having very specialized database to return you have a short budget of time to return an answer, right? So that usually you want a specialized store that does exactly that very fast, and you can't really compromise on this. But at the same time, there are a bunch of use cases where people want similar functionality on something, maybe like just the blob storage, just like in my warehouse, and I can still do a little bit of that even if it's not as optimized. I think the gap will reduce. Like you see it with like people, like it pushes into Parquet. Oh, now we can have a wide schema. Like how do we improve Parquet so it's less bad at doing that, right? So it's possibly people will not use Parquet to serve their vector database, right? But at the same time, in some cases, it will be good enough and the gap will reduce, and maybe there'll be more of those use cases coming through that area, even if like for a bunch of specialized cases, you do need like they're fully optimized to this one use case database. It's like my perspective.
This is like maybe a slight tangent, but I wonder if we'll see something similar to like the Lucene-based systems where there's like a online in-memory component, and that part will live in the catalog or somewhere that's used for the hot writes, and then everything else just goes to Blobstar. Oh, sorry, my bad. Anyways, I'm just wondering if we'll like steal some patterns from other systems that have had this problem of having their data represented primarily on disk, but still wanting a little bit of it faster than disk or blob storage will actually allow us to go. And I think we can, and I think someone will. Probably not me, though. I'm tired. Yeah.
All right, I think that's a good place to give a shout out to PuppyGraph, who's sponsoring this event as well. They're a graph database that also works off of Iceberg. So if you want to learn more, Waymo's sitting right there, and they have a booth. Okay, so let's talk more specifically about Iceberg. What's missing? What do you think is missing in the Iceberg spec today? What's being actively worked on, and what's something that's on your wish list?
Well, I'm kind of reiterating what I said before, but streaming. That's our priority. And by the way, anyone in the crowd thinking about contributing in streaming or has streaming problems with Iceberg, talk to us. We want to contribute more to the Iceberg project around this area in the, let's call it a school year new resolution. And other than that, let's see what you...
Okay, I can see. So, I started from the why Iceberg happened, right? And it's kind of, there's this notion of reducing silos and avoiding vendor lock-in. So you kind of, to do that, you move your storage layer as an independent piece you can interconnect, right? But that means now we have a bunch of tables. And when you think about a warehouse, you have a bunch of tables, but they're organized in schemas. They have like owners, and maybe I do access control. Who owns what, right? Who has access to what? And then the other thing you want is making sure I have lineage. I know that, okay, this is the tier that's the output of modeling, and this is the tier of tables you should be querying, and this is the raw table that just come from ingestion, and don't look at them. We haven't removed the spam from this one. Look at the other table, right? So there's a whole bunch of the data management that comes with having my warehouse in one place. And I think Iceberg will more and more, and maybe that's what the Iceberg catalog is for, right? Like having more of making this look like the same that when you look at your warehouse somewhere else, like in the data warehouse, and you have governance, compliance, all of that. And so in some ways we have ways to fix this, right? It's kind of, but I think it needs to become more like standardized and built in, and it's kind of part of this. That's what I can think of.
Yeah, so those I obviously agree with. I would say that the security maybe in the default is an area of room for growth. This is being recorded. I think there's a habit of security features being available for money, and I understand that. But I think it would be really nice if that was not the case. Probably catalog is where that needs to live, but who knows? You could do some of it in Iceberg too, but I think primarily the catalog.
All right, I'm going to start a flame war now. I would say diversity and interoperability. I would say in diversity, like I've been involved in a lot of communities. I'm actually not a committer on Iceberg. I'm not super involved in the day-to-day operations, but I have done some analysis. I was on it. And God, that word analysis came out weird. Some analysis on it. And I think that when you look at sort of the project versus other projects, there has historically been a fairly small group of people who control this core specification. And it doesn't mean that there aren't lots of people contributing lots of different things in the community, but I would really like to see more diversity around the direction that the core specification has, in terms of, and just more people involved in that, making decisions around that. There's this, if you've heard of BDFL, Benevolent Dictator for Life, it's a risky pattern that can't exist in open source projects. And I wouldn't say that Iceberg is that. Apache project should never be that, but there's de facto and there's de jure. And I think that Iceberg has been a little bit that. And so getting that decision-making more and more distributed and diverse, and being less reliant on any one individual, I think is something that I think it would be an improvement for Iceberg. I know that's not a technical answer. So on the technical side of things, I think interoperability, right? Like this is always challenging with a specification that's implemented in a lot of different systems where it's implemented separately, right? It isn't like there's a reference implementation everybody uses. There is a reference implementation, but a lot of people kind of roll their own Iceberg integrations. And what that means is that if the feature speed is fast, which it is in Iceberg, there's lots of new features coming all the time, then that means that everybody's kind of at a different stage of support of those features, right? And so he just gave the scenario of like, hey, if you want to do streaming writes and reads with Iceberg, it works great with Trino, but if you want to go use it with Snowflake, tough luck, right? And there's a lot of that right now, and it's part of being a fairly young technology in terms of its like this stage of adoption, but it's something that I think we need to work on is really getting it to the point where there isn't a gotcha every time you go from system 1 to system 2, right? Like, oh, well, that doesn't support deletion vectors and that one does, or that one doesn't support this data type and that one does, or any of those kinds of patterns. And so I think those are two key things that I think we can improve on as a community is diversity, which in part looks at every one of you. Like, hey, can you guys come and gals come and contribute and add to the project? Because diversity comes from volunteer work, right? It doesn't come from the people who are already working on it just being more diverse, right? And the interoperability one, I think, is more about time than effort. I think everybody knows it's something that could be better. Like the fragmentation around catalogs that exists is getting better. And I think that the fragmentation around some of these other things, as things get more mature, like the 99th feature is not as important as the 10th feature. And we're kind of in the stage right now where we're on the 10th feature. So you're like, oh, the 10th feature is so important. Yes, I definitely need that. And so then you're like, oh, I'm going to use the system that supports that. And then a bunch of other systems don't. When it's the 99th feature, you're like, well, I've got most of the most important features. And so if that 99th feature, I don't use that 99th feature until it's available in 6 systems, it's not that big a deal. So I think those are things that could be worked on.
I generally agree. The one place is the volunteer. So I think if we look at a lot of ASF projects, officially everyone is a volunteer. And yes, we are all doing it for ourselves, but many of us have jobs that pay us money because living is expensive, because we decided capitalism is a good idea. I don't know if I was involved in that decision, but that's another conversation. I have a green card, but I don't have citizenship. I'm not a communist, et cetera, et cetera. But it's literally one of the questions they ask you. Yeah. Oh God. I hope that for a lot of reasons, none of which I'm going to say on camera, most of which you can probably infer. Yeah. But yeah, so I think part of it is definitely volunteers, but I also don't want people to think that like everyone is just doing this in their spare time. I think this is a thing which sometimes it happens in writing, where people are like, how do you have time for writing? And the answer sometimes for non-technical writing is rich parents. Not my case. My answer is I have a day job and I work very hard. But like, it's important to know that like sometimes other people are paying for this, and that's not bad, and we should accept that. But definitely more volunteers always good.
I think that's a really good full circle moment to wrap this panel up on. We're back to open source and contributing, the importance of contributing to open source and how easy it is to get started. With that, so we're going to close out the morning session. Those all the talks and then the panels, and I can't thank all the speakers enough, including Holden, Julien, Jacques, and Lisa, who's sitting over there. Thank you so much.